Hello everyone. In the previous video, we learned about how can we connect MPU6050 with a microcontroller. And today we will be learning about how can we write a software for interfacing MPU6050. To write the code, we use a software called Arduino IDE. When you open the software, you can see void setup and void loop. If you write anything above void setup, then it is like a global announcement. It will be valid throughout the code. If you write anything in void setup, then it will be executed only once. And if you write anything in void loop, then it will be executed for infinite times. So let's go through the code for interfacing MPU6050. In void setup, we first wait for the serial port to connect. If MPU6050 is not connected, then we have a message that gets printed. Then we have a delay for 3 seconds, and after that we set the accelerometer range to 16G. That's because rockets, they fly with a really high acceleration. Now we need to calibrate MPU6050. When the sensor is stationary, you expect to see 0, 0, 0 about all 3 axes. But that is not what you get to see. There's always a little offset. For example, if a sensor is stationary, then you expect to see 0 about x-axis. But instead of that, you're getting 0.3, 0.31, 0.301, so on and so forth. To calibrate the sensor, we add all these readings and then we divided it by the number of readings to get the average offset. Using these instructions, you can determine the value for linear acceleration and angular rate. To get the accurate values of the acceleration and the angular rate, what we do is we subtract the offset that we calculated earlier from the current values. Now by using the value for angular rate, you can determine the current angle. For that we use an equation which is current angle is equal to the initial angle plus the angular rate multiplied by change in time. Then we use a complementary filter to combine the data from accelerometers and gyroscopic sensors to get the value for roll, pitch and yaw. So this is how we write a software to interface MPU6050 for determining the orientation and the position of the rocket.